Hi, my name is Raqib Azrai. I'm the group leader of this presentation. My group and I are gonna present about AC motor. So, enjoy! AC motor. As we know that generator converts mechanical energy to electrical energy, but AC motor works inversely as it changes electrical energy into mechanical energy. AC motor is well suited for constant speed application. This is because the speed determined by the frequency and the AC voltage applied to the terminal of motors. The rotating magnetic field is the key to operate the most of AC motors. There are several types of AC motor. Firstly is induction. Induction we have three: single phase, two phase, and three phase. Secondly, synchronous, hysteresis, and shaded pole. Okay, synchronous and induction type are two types of AC motor that are famous and mostly used on the aircraft system. Both types of motor rely on the magnetic fields in their stator to cause the rotor or armature to run. A magnetic stator can be made to rotate electrically around and around. Because of this, rotor is free to turn. Follows the rotating magnetic field in the stator. Rotating magnetic field is set up in two phases or three phases machines. To establish a rotating magnetic field in a motor stator, the number of pair poles must be same as the number of phase in the applied voltage. But wait, what is stator? What is rotor armature? So let's go deep into the detail. I'm gonna explain a little bit detail about induction motor. Induction motor is most common used type of AC motor. It is simple, rugged, and the construction are very simple but strong. It can be single phase, two phase, or three phase based on the number of pair poles in the stator. Most induction motor used in we can see washing machines or the refrigerators compressor at the back of the refrigerators, and etc. The construction of the induction AC motor consists of two main. We have rotor or armature or stator. Induction AC motor does not require commutator or slip ring as AC generator because the alternating current changes its direction rapidly, so it also changes the direction of produced magnetic field. The construction is very based on the phase, to be exact, vary in the stator. Okay, let's look the detail about the stator. Stator is the stationary part of motor where the pair poles is located. It has connection with the power supply, the place where the rotating magnetic field is produced. Okay. Next is rotor. Rotor is also known as armature. That one. Armature does not has connection with the power supply, has winding or bars. that are cut by the rotating magnetic field on the stator, and the torque is produced. It will rotate. Okay, this is serious. Let's talk about the principle of operation AC induction motor. The motor principle applies by the Fleming left hand rule. Okay. To make it simple, I already invented acronyms for us to understand. I call it FMC. This is force. This is magnet. North to south, the direction of the magnet. It is direction of the current. F, force. M, magnet. C is current. This is Fleming left hand rule. Applies on the AC motor. AC generator applies right hand Fleming rule. Don't be confused. Okay, let's see. The bars experience the force acting on it, and the conductor tends to follow the movement of the field. As we can see down there. Okay, two-phase induction motor. Oh, before that, AC induction motor also relies on Faraday's law. Faraday's law state that when the field cuts the coil, or the coil cuts the field, the EMF is produced. EMF is produced. And the lens, of course, lens. Okay, back to the two-phase induction motor. We can see that two-phase have two loops. First is at the 0 point, we can see A. A is a control phase for a reversal rotation. The negative side is B. We call it reference phase, has a fixed supply. Okay, let's go into the detail. At the position 1, position 1 is the 0 degree. The current phase of A is 0 current. In the phase B, you see the B, you see the B there. B is negative, which makes B1 and B1 north, and B is south pole. We go to the next. Next is position 2, 60 degree. The current in phase A, you see the A, current phase A is positive, and B is negative, which make A north pole, and A1 is south pole. B1 north pole, and B is south pole. Yes, like I said, just so from the position 1 and 2, the resultant field are now rotating in anti-clockwise direction. Rotating field speed set up on the stator winding, which cause the rotor speed to align with this field. The speed of the rotation depends on the input frequency. to reverse the direction is by reverse the connection to the control phase only. Application in the servo motors in instrument system. Okay. Two phase done, single phase is done. Let's go to the three phase induction motor. This might be complicated, but I'll try to explain it less complicated. Okay, from the position 1, as usual, 0 degree. The current phase A. Oh, before that, we can see that three phase we have just now. Two phase we have A and B, right? Three phase we have A, B, and C. That's why we call three phase, right? Makes sense. So at the position 1, current phase A is 0. The 1 is 0. Phase C is positive, flowing C to C1, makes it C north pole and C1 is south pole. Current B is negative, like the starting two phase. B is negative. Direction, the flows is B1 to B, makes B south and B1 is north. The two fields combine to produce the resultant field, which lies the direction shown by the dotted lines. Okay. Position 2. Position 2, 60 degree. The current in phase C is 0. Current in phase A is See that current phase A is positive, making A north and A1 south. So the flow is from A to A1. The current in phase B is still negative, as B remains south and B1 remain north pole. The resultant field has now rotates and continue rotates through all the positions. Okay, noted that application of the three-phase AC supply produce a magnetic field that rotates at the speed determined by the input frequency and the number of pair poles per phase. This rotating field on the stator winding is known as synchronous speed. Okay, so how to calculate the synchronous speed? Let's go for see the example down there. If the input frequency is 400 Hz, yeah, makes sense. Aircraft industry use 400 Hz frequency. Okay, if the input frequency was 400 Hz, then the rotating field would be synchronous speed 60 times frequency over 3, make it 8000 RPM. RPM is rotation per minute. Okay. The operation done. The construction done. So let's see about the characteristic of AC induction motor. There are two important characteristics of AC motors that need to be considered for any application running speeds and starting stops. The two characteristics of AC motors is running speed and starting torque. Let's talk about running speed first. Running speed is dependent on the power supply frequency, the number of motor poles, and the amount of slip. What is slip? Okay, it is the difference between synchronous speed and the speed of the rotor. You get it? The frequency and the number of poles define what the synchronous speed of the motor will be. As we can see down there, 1000, pardon, 1000, pardon, excuse me, 120 times frequency over the number of poles. We got for 2 poles, we got 3600 RPM. For the 4 poles, we got the 1800 RPM. This is number of poles, not the pair pole. So 2 poles means single phase. For 4 poles means 2 phase. Okay, the amount of speed, the amount of speed below the synchronous motor runs at expressed as a percent is defined as slip. Just now I mentioned slip. As the AC motor requires slip to induce current in the rotor, the amount of slip change as the load on the motor changes. Yep. In order to change the speed of AC motors, frequency must be changed. To accomplish by a motor control, commonly known as variable frequency drive. Let's alter the frequency. Without a control, the motor speed is fixed by the equation. Okay, the next characteristic is starting torque of the motor. In comparison to the other types of motor, starting torque is the chief limitation of an AC motor. A single phase motor will not start on, otherwise helped by load. Single phase motor are defined by the methods they are used to start. Some common types of single phase motor are shaded pole motor, split phase motor, the permanent split capacitor motor, also called single value capacitor motor, and the two value capacitor motor. All these motor types either use an out of phase secondary coil or a capacitor to create a secondary phase to start the motor. But remember, if your application require the motor to start with on load, consult your motor manufacturer to ensure that the motor has enough torque to start at the load, and ensure the correct motor type is specified for your application. In comparison to single phase motor, three phase motor has a higher power density, of course, and a higher starting torque, and also are more efficient than single phase motor. They start on their own, eliminating the needs for the starting windings or capacitor. The sum speed calculation applies of three motors as single motor. So the FFD variable variable frequency drive, it's required to change the motor speed. FFD change the frequency, then it will change the motor speed. Also, when the 3-phase power source is unavailable, controls are capable to converting single phase into the 3-phase power, making the 3-phase power more versatile. That's all from me. Against all the odds, but I'm calling it even. That's all from me. I would like to pass this presentation to my friend. Take it.
Thank you, Raqib, for the... Okay, hello everybody. I am Muhammad Hafizi Mekaniza, and this is my topic of the presentation, that is the method of speed control for the single phase, 2-phase and 3-phase AC induction motor. Okay, for the speed control of the single phase, there are many methods, but for this presentation I will only be going to present the method by changing the voltage frequency. Varying the voltage frequency affects both the motor speed and the strength of the magnetic field. Meaning, if the frequency is lowered, the magnetic field increases and excessive heat is generated. But if the frequency is increased, the magnetic field decreases and the less heat is generated. In order to keep the magnetic flux constant, the voltage Hertz ratio must remain constant. This keeps torque production stable regardless of frequency. For the 2-phase method of do it by changing the frequency. This method is very simple, as we only need to change the frequency. Increasing the frequency, the motor will dropping the frequency, the motor will slow down. Change that result will be proportional to the frequency change. Very simple. Phase method of speed control. There are many ways we can do it, either by adjusting the rotor side or adjusting the stator side. But for this presentation, I will only take the rotor side, and that is by injecting EMF. When the speed control of 3-phase induction motor is done by adding resistance in rotor, so-called the slip power is lost as I to the power of 2 are lost. Therefore, the efficiency of 3-phase induction motor is reduced by this method of speed control. The slip power loss can be recovered back by connecting an external source of EMF of slip frequency to the rotor circuit. The injected EMF can either oppose the rotor-induced EMF or aid the rotor-induced EMF. Okay. If the injected EMF opposes the rotor-induced EMF, the total rotor resistance increases and hence the speed is decreased. That means if the injected EMF aids the rotor-induced EMF, the total resistance increases and hence the speed. If the injected EMF aids the rotor-induced EMF, the total resistance decreases and hence the speed is increased. Okay, it is direct inversely proportional, meaning I will give it in a more simple form, meaning if the injected EMF opposes induced EMF, the rotor resistance increase, speed decrease. If the injected EMF aids rotor induced EMF, total resistance decrease, speed increase. We want to control the direction of rotation for the motor. The phase, we can do it by reversing the motor. Reversing the rotation of the motor is simply a matter of moving the power connection so that other winding is directed on the AC. Okay, moving one side of the power connection from A to B, you see there, the connected power A we change to B, causing winding O to be the main winding and winding M to be the phase shifted one. Okay, we can see this from this picture. We can see that M is the main power and O is the phase shifted one. But we change the direction. We change A to B and B to A, causing M to be the phase shifted one and O to be the main power one. Doing this will change the direction of rotation. Okay, from the graph taken from the graph where O is the phase shifted and M is the main. This graph shows that the rotation of motor is clockwise, but by simply changing the placing of winding A to B and B to A means that O will now become M and M will now become O. This will change the direction by the motor, by meaning that the motor will now rotate in a counterclockwise direction. In phase, we can control the direction of the motor rotation by interchanging any two of the three motor supply lines. And there is the picture. Let the phase sequence of the three-phase voltage applied to the station is XYZ. The top one, X being the red winding, Y being the yellow winding, and Z being the blue winding. If the sequence is changed to XZY, X being the blue winding, Y being the yellow winding, and Z being the red winding. We change the placing of the red winding and the yellow winding, as you can see from the reverse direction three-phase. If this sequence is changed, the direction of rotation change. The field rotates counterclockwise rather than clockwise. The forward direction, meaning the red is on top of the yellow, the motor will rotate in a clockwise direction. And we change the winding, meaning the red winding is on top at the bottom of the yellow winding in the reverse direction, meaning from the bottom picture, the one will rotate in a counterclockwise direction. However, the number of poles and the speed at which the magnetic field rotates remain unchanged. Nothing change except the direction of rotation. I am going to present the method of producing a rotating field for the single phase induction. Single phase motor works on the same principle as three-phase motor X. They are only run off one phase. Single phase set up an oscillating magnetic field that goes back and forth rather than a rotating magnetic field. Because of this, a true single phase motor has zero starting torque. However, once the torque begins to rotate, it will continue to rotate as a result of the oscillating magnetic field in the stator. Method of producing a rotating field for the three-phase. The motor rotates due to the rotating magnetic field in three-phase induction motor, which is produced by the stator winding in the air gap between the stator and the rotor. Is produced by the stator and motor. The air gaps between the stator and the motor, the rotating field, will produce at that place. The stator has a three-phase stationary winding, which can either be star connected or delta connected. Whenever the AC supply is connected to the stator winding, line currents IR, IY and IB start flowing. These line currents have phase difference of 120 with respect to each other. Due to each line current, the sinusoidal flux produced in the air gap. These flux have the same frequency as that of the line current, and they also have the same phase difference of 120 with respect to each other. This is all of the mathematical calculation of producing a rotating field. It is the effective or total flux in the air gap is equal to the phase sum of the three components of flux R flux Y and flux B, or the total flux equal to the flux R plus flux Y plus flux B. That's how we get the rotating field. I will now pass my presentation to the next presenter.
Okay, my name is Rasyiyudeen and I will introduce to you about a synchronous motor. So first thing first, and we put this over here. Okay, synchronous motor, the motor which run at synchronous speed. The synchronous speed is the constant speed at which motor generate electromagnetic force. It is used for converting the electrical energy into mechanical energy. Next, the construction of synchronous motor. It has two construction. It is first, the stator is a construct with thin silicon lamination and insulted by a surface coating. As axial load inside, which three-phase stator winding in place. The stator is wound with three-phase winding for a specific number of poles equal to the rotor pole. And next is the rotor. The rotor is this part. Okay, you can see. The rotor is mostly used salient pole rod type. DC supply is given to the rotor windings via slip rings. The direct current excite the rotor winding and create electromagnetic field. Next, we will see the principle of operation. The working of synchronous motor depend on the interaction of the magnetic field of the stator with the magnetic field of the rotor. The stator contains three-phase winding and is supplied with three-phase power. Thus, stator winding produce a three-phase rotating magnetic field. DC supplies is given to the rotor. The rotor enters into the rotating magnetic field produced by the stator winding and rotate in synchronization. Okay, we will more understand about this with this video. Okay, this is a synchronous motor. We will see. Okay, it's a little bit slow. Okay, synchronous motor is achieved by a rotating magnetic field, which is the stator, and the constant magnetic field, which is the rotor. The field called and stator is excited by the three-phase AC power supply, and it will produce revolving magnetic field which rotate at synchronous speed, while rotor is excited by the DC power supply, so it acts as a permanent magnet, and sometimes the rotor is made by a permanent magnet. So this is the fun fact about the interaction of rotor and the RMF. Okay, we will assume that the rotor is given additional rotation with same direction of RMF. So you can see the opposite pole of the RMF and rotor will attract each other and they will lock automatically. While this happens, rotor will rotate synchronously as the RMF. So this is the formula that we can use to obtain the synchronous. With the frequency of electricity frequency of electricity will affects the number of pole. We will continue with the slide. Next is the characteristic of synchronous motor. The speed is synchronous and does not depend on the load condition. Speed always remain constant from no load to full load. But okay, we can refresh from the induction motor. That induction motor have an effect by the load. As the load increase, the speed of the rotor will start to be low. But for the synchronous rotor, the speed is not depend on the load condition. But it depend on the angle of torque for the load. If the load affect the angle of torque more than the synchronous motor can handle, it will be a repulsive force and the synchronous motor will not be moved. The synchronous rotor will not move. Then next, the external force is required to start the synchronous motor as it has no starting torque. Then the power rating of synchronous motor range between 150 kilowatt to 15 megawatts. Highly efficient machine and their efficiency is much greater than induction motor. It uses brushless exciter which decrease the maintenance problem, and it has a high power factor correction. Next, is the method of speed control. Speed of the synchronous motor is controlled by the frequency of the applied current. The speed of synchronous motor can be calculated as shown. Okay, for this I have shown you by the video earlier, so we can skip this. Next is it's still the same method of the synchronicity. Okay, this is what I said earlier. If the load greater than breakdown load is applied, the motor get desynchronized. It means it has a repulsive force between the RMF and the rotor. Okay, next is the direction of rotation. The direction of rotation of synchronous motor is reversed by interchanging any two of three line lead feeding the stator winding. It means we have three stator. Okay, we can assume it as a A, B and C. So what we do is we change the wire for the B to the C and the C to the B, and this will affect the direction of rotation for the synchronous motor. And the direction of rotation of motor does not change if the two conduct of DC source are interchanged. It means for the rotor we have used the DC power supply, we have used the DC supply, so it does not change if the DC source are interchanged. Okay, that's all for me. Now we'll continue with the Kai.
Hi, my name is Khairul Hamza, and I will explain about hysteresis. Okay, actually I will explain about hysteresis motto. But before that, what it is hysteresis? Hysteresis is the phenomenon in which the value at a physical property lags behind chance in the effect, causing it, as for instance when magnetic induction lags behind the magnetic force. Okay, and hysteresis motor, a synchronous motor with a uniform air gap and without DC excitation, the rotor of which made of magnetic material with large remnants. It is residual magnetization which is started up due to hysteresis loss in rotor. It operates both in single and three phase. Okay. For the construction of hysteresis motor have 5 main components. You can see the picture first, and I will say five main components. It is stator, single phase stator winding, rotor, shaft, and shading coil. Okay, for the stator, a stator using permanent capacitor type construction, and bolts winding remain connect in the circuit during running operation as well as the start. Both the winding remain connect in the circuit during the value of capacitance is so just as to result in a flux revolving at synchronous speed. What is it? Synchronous speed. Synchronous speed is the speed of the revolution of the magnetic field in the stator winding of the rotor. For the rotor, a rotor consisting of smooth cylinder of magnetically hard steel without winding or teeth. Rotor is made of chrome steel. Why use chrome steel for the rotor? Because this motor have favorite features such as constant torque, low startup current, and noiseless operation. However, low efficiency and low power factor are common deficiencies of hysteresis motors. Suitable rotor substance and having accuracy in design considerations as possible. In general, magnetic property of the rotor material has the most important and plays as key role in the hysteresis motor performance. Get it? Okay. For the principle of operation, when stator is energized with single phase AC supply, rotating magnetic field is produced in stator. To maintain the rotating magnetic field, the main and auxiliary winding must be supplied continuously at start as well as in running condition. Get it? And at the starting by induction phenomenon, secondary voltage is induced in the rotor by stator rotating magnetic field. Hence, eddy current is generated to flow in the rotor and it develops rotor. Thus, eddy current torque is developed along with the hysteresis torque in the rotor. Hysteresis torque in the rotor developed as the rotor material is with high hysteresis loss property and high relativity. What is it? Hysteresis loss. Hysteresis loss is the power consumed by the magnetic domains for changing the orientation after every half cycle. Get it? So, the rotor goes under the sleep frequency before going to the steady state running condition. So it can be said that when the rotor starts to rotate with the help of the eddy current due to induction phenomenon is behave like a single phase induction motor. For the characteristic of hysteresis, a hysteresis motor can synchronize any load with it, can accelerate no matter how great the inertia. It is because the torque is uniform from standstill to synchronous speed. Hysteresis motor produce very smooth and soundless rotation. The rotor takes on the same number of pole as the stator field. Thus, by changing the number of stator poles through pole changing connection, we can get set of synchronous speed for the motor. For the additional, hysteresis motor actually useful for high quality record players and tape recorder. Okay. Direction of rotation for hysteresis is determined by the position of the shaded pole and with respect to main pole, which means the rotation is from unshaded coil to shaded coil. The reverse movement of rotation not possible. Okay, I will pass this pen to next presentator. Take Ayai.
Assalamualaikum, and my name is Muhammad Azrai, and today I would like to present to you about one of the main type of AC motor, which is shaded pole. So without further ado, let's go. So what is shaded pole? Shaded pole is a self-starting single-phase induction motor whose one of the pole is shaded by the copper ring. The copper ring is also called the shaded ring. This copper ring or shaded ring acts as a secondary winding for the motor. The shaded pole motor rotates only in one particular direction, and the reverse movement of the motor is not possible. The construction of the shaded pole induction motor has two main components, which is stator and rotor. For the stator, it is constructed with salient poles. What is salient poles? Salient poles means poles of the magnet are projected towards the armature of motor. Each pole has its own exciting pole, and the poles of motor are laminated to increase the strength of pole. For the rotor is the usual squirrel cage type. It is very simple because it does not contain any commutator, brushes, collector rings, and it also does not have any centrifugal switch. What is centrifugal switch? It is a type of electrical switch that starts operating by using centrifugal force generated by rotating shaft, and it also used for controlling the speed of the shaft. So by using this squirrel cage rotor, the chances of failure of the motor are less. So let's talk about the principle of operation. This shading coil arrangement displays the axis of the shaded poles from the axis of main poles. When power is applied to the stator, the flux in the main part of the pole induce a voltage in the shading coil, which acts as a transformer secondary winding. Since the current in the secondary winding of the transformer is out of phase with the current in the primary winding, the current in the shading coil is out of phase with the current in the main field winding. Thus, the flux of shading pole is out of phase with the flux of the main pole. This is the rotating field of the shaded pole motor. And for the characteristic, some of you may ask why shaded pole induction motor designs for low power rating. This is because shaded pole induction motor has poor efficiency because number one, the power losses are very high. Number two, the power factor of motor is low. Number three, the starting torque induced in the induction motor are very low. So the solution is their design are kept small and has low power rating. So for the application, it is used for small devices like relays and fans, sometimes exhaust fans, hair dryers, air conditioning, and refrigeration equipment. For the method of speed control, voltage only control of a shaded pole motor is an acceptable method and is the most common. It does not work on other types of AC motors because of some design aspects of what make shaded pole motor work in the first place. The direction of rotation of shaded pole motor depends on the position of shading coil because the direction is from unshaded side to the shaded side of the pole. So the reverse movement cannot be done unless the machine is constructed so that the shading coil can be shifted to another arm of the pole. So that's all from me for shaded pole induction.